In a world where space and time are intertwined, one man dared to challenge the status quo. His name? Dayton Miller. His weapon of choice? A flute. But not just any flute. This instrument held the power to unleash the ether, a pervasive medium once thought to fill the universe. Miller, a physicist by trade, a musician at heart, discovered a harmonic resonance within the ether. He found that his flute, when played with precision, could manipulate this elusive medium. His melodies, a symphony of science, had the potential to shift the very fabric of reality. However, a sinister force lurked in the shadows. The Einsteinian demons. These creatures thrived in the distortion of space-time, causing chaos and disruption. The world needed a hero, and Miller was ready to answer the call. With his flute in hand, Miller played it.
All right, ladies and gentlemen, we are live. Welcome to Aether Roundtable number 62. Tonight, I'm going to be doing a presentation on Airy's success. So, a little history recap. In 1871, a man put water in a telescope and tried to measure a difference in the angle, in the zenith angle of a star, to see if the refractive medium would change the angle of the star, and that would be evidence that the Earth is actually the causal mechanism of what's in motion. So we're going to go over the full scope of the history of the experiment, and we're going to look at the modern refutations that are put forward. So like the relativistic paradigm and a couple other explanations in regards to how light travels. So we'll get into all those. So a couple of prerequisite things that we'll go over so that we can all get a baseline of understanding of what's being discussed here. These measurements are done in arc seconds. So here's how we can conceptualize an arc second. If you take a protractor, look at the distance between 1 and 2 degrees, break that up into 60 sections, you would have 60 arc minutes per 1 degree. And then you can break 1 minute and up into 60 seconds. So you can further break a degree down to 3,600th of a degree. And then you can further get into milliarcs and microarcs, but we're not going to be in that range. But for other astronomical purposes, they do claim to have a resolution of 3,600,000th of a degree and 3,600,000,000th of a degree. But those aren't going to be what's discussed here. We'll be in the arc second range. So viewing conditions of the sky, this is quoted from McRoberts in 1955, where it says, viewed at a high power from the bottom of our ocean of air, a star is a living thing. It jumps, quivers, and ripples tirelessly or swells into a steady ball of fuzz. Rare is the night, and at most sites, when any telescope, no matter how large its aperture or perfect its optics, can resolve a detail finer than 1 arc second. More typically, or at ordinary locations, is the 2 to 3 arc seconds of seeing, or even worse. And of course, we're talking about for 1 arc second, you would be doing zenith observation. So you're looking straight up above you, and that's going to give you the least amount of refraction. You're going to have the least angle of incidence to the medium that you're looking through. So what's going to be discussed is the positions of the stars and what they see in the sky, and how that's interpreted for their cosmological belief. So a big topic that's going to be discussed tonight is the difference between true position and apparent position. So to kind of conceptualize that, we have a lad here on Earth. He's looking up at the stars. Suppose this is the actual location, but because the light comes in and hits the refractive index of air, its position is shifted slightly. Now these angles are greatly exaggerated, so you can easily conceptualize it. These would be slight differences, but this is what they're putting forward. So when you're looking up at the sky, you're not seeing the quote unquote true position of a star. Everything you see is an apparent position, and that applies to all celestial bodies, the sun, moon, the so-called planets or wandering stars, and the fixed stars and all that, and the zodiac, all of that stuff. All right, so when we get into this experiment and its purpose and the interpretation, it's very important to understand that we're giving like a huge benefit of the doubt to the idea of a true position of a star, because everything in the sky is always in motion. So how do you establish where the star actually is in reality? Well, you wouldn't be, you would just kind of be taking a guess at it. So how they have established these true positions is off what's called the first cusp of Aries. And this is established for celestial navigation, and it's in all the old almanacs. This is the baseline for the true positions of the stars. So this is a snapshot of the position of the stars on the vernal equinox. And from that day moving forward, it's all the stars, will deviate from that, and then they'll complete a cycle. And it's when they return to that position, they're all expected to, return at the same position and all that. And what they found is that if you take that day, that snapshot, which is arbitrary, right? Because they're all, your mic keeps slip smacking. It sounds okay. Thanks, Beast. 1 second. All right. Knox. So because everything's moving in the sky, there's no true position, but so this is a great, leap of faith to extend this to argue. So, but anyway, what they say is that when they do these measurements over the course of a year, there's actually a little drift of the tune of 20 arc seconds. So the stars will be slightly out of position by 20 arc seconds, they say. And when you take that ratio over the speed of light, you get the corresponding angle for the deviation from perfect 90 degrees on a zenny. And they relate that to the only thing that could produce that is Earth's motion, because the ratio of that angle comes out to be 30 kilometers a second, which happens to be the necessary orbital velocity for the Copernican principle and for Kepler's laws in Newtonian dynamics to be true. So it's important to explain how this works on a flat Earth for our cosmology, because people will try to make the argument, oh, this is just, you're now arguing for a geocentric globe, et cetera, et cetera. Well, no. Let's take a look at what a map is, how it's made, and what we see in the sky in relation to that map. So here at the equator, we have divergent star fields, and we have the respective north and south rotations, and that would be due to toroidal geometry. So the star field in the north, and then that would get projected out in the south, where it diverges away from the north. Now, if you have a limit of vision and you're interpreting these projections of star fields through toroidal geometry in the sky, how could you map that? What would that look like on a map? What could you do? Well, suppose you're in the center of this fundamental plane here, and you see the sky and everything move around you. This is what it would look like. And then when things go out of your field of vision, when they leave your field of view, they're going to appear to go into the horizon. They're going to appear to set into the horizon. Now, are they blocked by Earth curvature and rotation away from them? Or is it due to the limit of your vision? Well, mathematically, you would represent this effect the exact same way, and you would just use a negative coordinate system to represent where you don't see the stars. And they would complete a circuit above you or underneath you as you rotate away from them. And that mathematical equivalence is the only thing that distinguishes that is just how you define the coordinate system to represent it. So when you represent it through a ball like that, where the top northern hemisphere you would say is the top of the ball, and the southern hemisphere is the southern half of the ball. Well, that would just be the merger of two coordinate systems with respect to the limit of your vision. So, and when we get into the position of the stars, we have a northern and southern hemisphere star chart here for the position of the stars and the zodiacs. And when you would merge these two star fields together, right? When we take this and merge it together to make it into a map that you could use in any hemisphere, that's what you end up with what they call the globe, but that's just a graticule, then the globe is just one of the projections of the graticule. So this is what an equidistant concentric circle layout would look like for the star map, everything we see in the sky. So this would be like if you can imagine a Gleason's map, this would be, you know, where the stars would look like in the sky. So no difference there. It's all just in the coordinate system of how it's mapped for the interpretation. Any questions so far before we move on?
What a great representation.
Thank you, sir. Okay.
Can we go back about 3 frames
Yes, sir.
to the one that where you showed the celestial?
This one?
Keep going back there. One more. Maybe 2 more, actually. Go back. Past that one. There it is. That's the guy.
Mm-hmm.
Yeah, it's all about the observation and where you are on Earth when, say, someone like Airy is making that observation during the equinox. That, hold on, let me refer to my own diagram and how that relates to yours. Right, so you're looking into the lean, and the transverse is pointing at noon. Okay, so that means, yeah, so technically the sun at this point would be in the direction of the black arrow pointing at the vernal equinox. So if you can actually picture the motion of the Earth would be along that line. And you're viewing the star here at either dawn or dusk when the sun is 90 degrees from your zenith. Hopefully that's a little clearer about when the observation and where on Earth it's being taken. Hopefully we'll revisit that. But I just wanted to fill that in.
Yeah, thank you. Much appreciated.
And real quick, just a brief explanation of the graticule.
Graticule.
Were you offering one?
No. Could you
yeah. So
real quick?
Yeah, it's a spherical coordinate system that uses latitude and longitude. So when people say, okay, we're using an AE map and this is a flat Earth map, and then they pull up a Mercator or any other type of map and they're like, this is a different, this is a globe map. Well, they're actually all the same because it's all in relation to the coordinate system and how it's used. So if you were going to take 2 different star fields that you see in a dome of vision and merge them together to a coordinate system that you could project into equidistant circles or equidistant concentric circles or little equidistant squares, so you could do like, plane sailing, they call it, stuff like that, like different uses. This is how you would use that spherical coordinate system to merge those 2 together for symmetry.
And be equivalent.
Yep.
Good old graticules.
Yep. Because so it's just a map of the position of the star. So when you think like northern hemisphere, it's just like where the position of the stars at if when you're in the north to see them.
The zenith zones.
Yes, sir. Them zennies, they call them on the streets.
Mapped by the zennies. By the zennies, bro.
I heard some kids saying it the other day. They were like, those zenny angles. And I was like, nice. Those kids get it.
Propagating nicely. Yeah.
Those random street kids get it. All right. So the next thing we're going to look at here is the speed of light in water. So a big argument that's put forward for Airy's failure and misinterpretation, and we'll look at some gaslighting here later, is that the speed of light doesn't change in a medium. Well, it absolutely does. Now, there's various explanations as to, does it actually change, or is the light bouncing around the molecular structure of the medium? Is it interacting with the electrons and then those are re-emitting the light? Like, what's going on there? Is it actually slowing down or what? Well, we're going to get a definitive measurement here to kind of put that to rest so that we can all get back on the same page and understand that when light enters a medium, it goes slower. So this is Looking Glass Universe, or what is their channel? Yeah, Looking Glass. And she's going to do an experiment here with a laser meter and a tub full of water. She's going to measure some distances based off of the timing of the speed of light.
Okay, gives me one of the test. Yeah.
And
And now what I'm going to do is that same experiment again. I'm going to test how far this meter thinks the distance is from the top of this jug to the bottom. And I'm going to do it once without water and then once with water. Okay, it gives me 11.2 centimeters. If the old distance is like 11 centimeters, then the new distance should be approximately something around 14.5. Okay, so if the result is like approximately 11 centimeters, then that means that the speed of light in water is about the same, whereas if it's about 14.5, then it means that the speed is significantly slower. So let's see.
That would be a 30% difference in velocity.
Okay. Aiming for about the same spot, and okay. I think that's a positive result.
Yeah, that's
so
a
we're
good
thinking
third.
about maybe
different.
whether this doesn't.
Yeah, freaked out and pulled the Homer Simpson meme. She went to bed. She was like, "What is this place? What am I doing?"
Dude, so quick background.
Refreshed.
Quick background. She's a PhD in quantum mechanics, and during the lockdowns a couple years ago, she's the one that did the double slit experiment, and she used a fog machine to show that the light diffraction pattern happens all throughout the experiment. So at no point is there a particle photon or whatever. And then she did this one after that to measure the speed of light and does it change in a medium. And her initial hypothesis was that it doesn't change. And she had like various explanations as to why and did some mathematical analysis to kind of like trick herself into explaining how it would do that. And then we're at the end here where she buys the thing and does the experiment. And yeah, so what she just measured was a timing difference in the speed of light. So she got a different distance, right? That corresponded to that 30% change that Stone just mentioned. So the speed of light in a medium changes. It doesn't, you can argue philosophically like, yeah, it stays the same, but it's bouncing around the molecular structure. Well, either way, that timing difference creates a distance change. So to argue that that doesn't happen and that's not a real effect, you're now arguing against observable reality and things that are easily measured. This is a huge point of contention in this argument. I know because I went through.
Open your hand.
I went through your hot, Mike and JT. I went through and watched a bunch of videos to see what the modern refutations were. And since we've been arguing this, a lot of people are like, light doesn't change its speed in the water, that therefore it's not going to have an angle change and all these things. And it's like we just watched the speed of light measurably be different in a medium. So, and then I'll put the link to her in the chat so you guys can swoop that up if you need it.
Thank you, brother.
Mm-hmm. All right, now we'll continue on to the history of Earth's motion. So before we had, because you'll often hear references to like, well, we know the Earth's in motion, the previous XYZ of Earth's motion, like there was this long list of mysterious experiments that no one's ever heard of that prove mutually exclusively that the Earth's in motion. There's only like 2 or 3. And it starts with stellar parallax, which is the apparent shift in the position of the stars with respect to the time of year. And the heliocentric interpretation of that is that if you triangulate the position of the stars in the change, if you use the baseline of the triangle as the distance from Earth to the sun, and then, completing its orbit where it'll be in a different spot. So you take 93 million miles, add it up for 186 million miles, and you take that for the baseline of the triangle, you extend that out to dang near infinity where, trust us, it converges. They take that as the causal mechanism for the apparent displacement. And the thing with the triangle is, though, if you reverse it, the geocentric equivalent would be just the skies moving to create the baseline. So the star's motion creates the baseline, and then your position where you view it optically is where the triangle converges. So there's a direct equivalence there with this measurement. This is kinematics. This doesn't prove anything with respect to is the Earth moving or does the sky move. These are direct. This observation has a direct geocentric equivalent, and we'll actually take a look here at a counter argument to heliocentrism, because in heliocentrism, suppose that the parallax is caused by Earth's motion. Well, then you're locked into the parallax all has to go in the same direction. And we're going to read a little bit here from a paper from 1943, where they talk about the what to do when they measure negative parallax. So this is from the Dearborn Observatory, 1934, and
I have a quick point to that when you're done with this, if that's okay.
Yeah, awesome. Yeah, no worries. So he gives 3 explanations here on how to handle negative parallax. The first explanation is it's just an illusion. You know, it's a statistical anomaly. Here's some nice math to cancel it out. The math was supplied by our boy Frank Dyson, and he was the statistical analysis mathematical wizard lad that helped Eddington do his analysis for the eclipse observations. And then the second explanation is, well, perhaps the star system is a binary star system and it has an irregular movement and it just looks like it's negative, but it's really positive, and it's just due to some velocity anomaly because of the gravitational exchange between 2 bodies that are really close to each other. It's going to produce irregular movements, and maybe that's what did it. And then the third is that maybe the reference star that they're using moved and they should use a different reference star. Well, that's that's cool, man. That's cool. So that's completely, now it's unfalsifiable at this point, where no matter what they see in the sky, it's going to prove heliocentrism mutually exclusive, even if the parallax goes in the opposite direction of motion. They're going to chalk it up as a W. So that's that's what they'll invoke. And then the other thing that will be invoked is stellar aberration. Oh, I'm sorry. Did you want to get in, do your thing real quick, Joe?
Yeah. I've come to really think that this parallax they're talking about is relative to the sun's travel between the tropics, and it's causing this optical shift due to the reflective sky, the toroidal dome, superfluid reflective sky, and the sun's position. It causes this optical shift. Like for example, Orion. Like right now, Orion comes basically up to my zenith and then goes off to the west. Whereas later in the year, it's going to kind of rotate low around my horizon as it moves back across the equator. So Orion is shifting with the sun. As the sun crosses the equator and goes towards Capricorn, Orion comes north of the equator slightly. And then when the sun comes back to Cancer, Orion shifts back to south of the equator slightly. It seems to be in relation to the sun's travel between the tropics that's causing this optical shift of the stars, if that makes sense.
Yeah, I don't know.
Could be the whole sky that way too. Then everything just shifts with the path of the sun driving the force, right? We don't know which one's pulling which, but they both move together. That's evident.
Yeah.
It's definitely possible.
So there's a secondary measurement that was taken that is touted as mutually exclusive evidence because the ratio of the angle gives 30 kilometers a second. And this was measured by James Bradley in 1727. So going all the way back to there, we're looking at his setup here. He had a zenith telescope setup where he was measuring a star called Gamma Draconis. And with that, he found that he had to tilt his telescope forward slightly to keep the star in the center of the telescope. And the implication of that, so the deviation from a perfect 90 degrees versus how much he had to tilt it to keep it in the center, he was interpreting that as as being caused by Earth's motion with that specific angle. So keep in mind, this is a deviation from where they would say the true position of the star is. So they got their direct 90 degrees any measurement, their idealized position, right? And then this dude is saying that it's slightly off for some reason. He has to tilt his telescope forward a little bit. Now, the causal mechanism for that they were all believing in was that it was the Earth that was doing it. So we'll look at the ratio here. The arctan times the velocity of Earth over the speed of light gives you the angle of deviation in the star. So the amount that he had to tilt, he was like, this angle with this ratio is 30 kilometers a second. Our model just happens to be based on an Earth that moves at 30 kilometers a second. So that's a really good proof for us. And on top of that, this is actually a double proof for globular arguments, because the observations are latitude dependent and they have different effects. So they say, due to the contour of the Earth, you'll see a different effects at different latitudes. So at the North Pole, you would see a perfect circle. So this arc drift over the course of a year, it would make like a perfect circle type shape that would complete itself. And then if you're at around the 45th latitudes, you would see kind of like it would start to be like an egg shape, kind of like an oval. And then as you get closer to the equator, it becomes an ellipse. And then at the equator, it becomes a straight up line. So as we were talking about earlier with toroidal geometry and the limits of our vision and how we see this projected star field, that argument is like, it's no longer mutually exclusive to being due to parallel light rays coming in due to and then the difference being caused by the contour of the Earth. That would just be an optical phenomenon with respect to a flat stationary plane. So, again, this was a huge proof for the heliocentrism. It was because the angle gives a good ratio, gives good agreement, but it is giving them a massive, you're really entering their realm when you accept the true position of a star, because like I said, they're always in motion. They don't have an actual true position. This is just an idealized position that they came up with to use for maps. All right. So a couple of experiments that were done before we get to Aries were experiments with telescopes to determine whether or not the Earth is actually moving. So far we've got a nice ratio here and an angle where the refractive index is air. And then the next proposal was by Arago in 1818, who hypothesized that he would have to change his focal length in his telescope when the Earth is perihelion and aphelion. So you would be moving towards the stars or away from them. He thought that he would have to adjust his telescope to keep them in focus. And he found that he didn't have to make any adjustments, which, Can
I add something?
Absolutely.
Yeah, I mean, this is something I find interesting, and it just kind of relates to this. Like, when I go out and I set my telescope up, once I achieve prime focus, I can shoot any target anywhere in the sky and get great pictures.
Yeah.
And if these things are rated by millions of light years and trillions of light years, I should have to refocus every time I move to a new target to get good pictures, and I don't.
Yeah, and I've also heard that if you can't get good focus for the night, turn your telescope to the moon and then bring that into focus. And if you can get the moon into focus, everything else will be in focus. But I've never telescoped, but I've heard that's a thing that the telescope lads do.
Yeah, I mean, it'll give you decent focus. I would prefer to do something like a really bright star like Jupiter, Venus, any of the really bright. Sirius would be a good one. Any really bright star. But I mean, the moon is so much closer to us, it seems, that your imaging, if you just focus on it, it's not going to be as good as if you do it on a star.
Nice. All right, so the next experiment that was done was by Arago again. And this time he decided to half cover his telescope with a crystal prism. And the idea is that to keep when the starlight intersected with the half covered prism, he would have to further adjust his telescope to keep the starlight in the direct center. And what he found was when the starlight intersects with the crystal prism, there's no angle change required, which means that the light already comes in at that angle. So here, by introducing refractive mediums that would necessitate an angle change due to the timing difference it takes for light to travel through the medium, thus the time that Earth will be moved out of position from under light before it hits your eye, will cause that angle to be greater. And there's no one's measuring an angle change there. No one's having to adjust the focal length of their telescopes 6 months of the year, and no change in a refractive medium. So the implication is that the starlight is already coming in at an angle, and that it doesn't require that would be the only reason that it doesn't require a greater angle change if the Earth is stationary. So we have an analysis from Whitaker who says Arago submitted the test to experiment and concluded that the light incoming from star behaves in all cases of reflection and refraction precisely as if it would if the star were situated at a place at which it appears to occupy in consequence of the aberration and the Earth were at rest. So the apparent refraction in a moving prism is equal to the absolute refraction of a fixed prism. So here he's generously asserting that the apparent refraction in a moving medium is the same as a fixed prism. And it's like, well, no, you're just assuming that the Earth is moving and that doesn't affect it when it absolutely would. But we're almost about to get to Aries here. We just got a couple more things that are super relevant to the experiment and why he did this. The next up is Fazal's experiment, where he tested the hypothesis of Fresnel drag, and that was that the ether was a material medium that was stationary, but it could be dragged by another material medium. So Fazal came up with an interferometer that splits a light beam that goes through a rectangle, that goes through a water tube, where the light beam will go with and against the flow of water. And what he found was that the translational velocity of the water was measured with a 44% ratio independent of the refractive index. So they know light's going to be slowed down in the water, but it shouldn't translate any velocity component to the water unless there's something to drag it along, and that's what they measured. So they measured 44% of the water velocity going with and against for a total of 88% of the velocity of the water.
That's
So they
super clever, by the way.
Yeah, it's pretty tight. So they showed that not only does the speed of light change in a refractive medium, in a medium, it changes in with the velocity of that medium as well. So now we're going to get into a guy named Klinkerfuse and what he did and what he derived and what he claimed to measure with respect to this angle change and refractive mediums and stuff. So here Klinkerfuse says from his 1867 paper, the aberration of the fixed stars. Under the term aberration, two different processes are almost always combined in the writings dealing with this subject. First, the delusion, which we are subject to by the direction of the ray owing to the motion of our own point of view, in which we are quite comparable, is that of which we fell in a fast-moving carriage or a railway over the direction of pouring rain. Secondly, the real change in the direction of the ray, which also causes the movement of the Earth as well. So caused by it's translated or whatever, but caused by the movement of the Earth. The former may be called psychological, and the latter part be physical aberration. So we're talking about the assumption that the Earth is in motion, and the causal mechanism for the displacement is this motion. So people will try to argue that this experiment had nothing to do with Earth's motion, and that because of aberration, they already knew the Earth was moving. And it's like, no, the aberration is kinematics. It can't tell you if the sky is moving or if the Earth is moving to cause that angle change. You would have to introduce another variable to cause a dynamic asymmetry in the situation so you could make a definitive analysis. So what he's going to be putting forward is that, introducing a refractive medium. So confounding the two different effects under the concepts of aberration, by aberration being understood to mean the total and apparent and real change in the direction of the ray caused by Earth's motion, has been nothing less than a favorable treatment on the object. Even in the consideration of the expediency of the sharp limitation of the concept of the terminology would suffice to find the combination of the two processes, which are related by a common origin, but incidentally different, not very advantageous. But it also adds to the two parts of aberration in the very difficulty of the treatment. So trying to come up with a way to distinguish between the apparent effect and is this really due to Earth's motion is what we're talking about here. So we'll read a little bit more. This remark essentially pronounced by Fresnel's other words, thus gives the property of important theory of aberration in the way of physical aberration is altered when the ray is deflected by the refraction or reflection, or what appears to be quite the same influence of Earth's motion on the refraction and reflection. Since we obtained this by way of experience independently of any hypothesis about the translatory motion of the flow of the ether, then we have the same time gained for the latter experience. So as he's breaking this down, this experiment, people will try to say, well, Airy failed to detect the ether. We know that stellar aberration, blah, blah, blah. Nope. The refractive index necessitates a timing difference, which is going to mean the Earth gets to move further, which is going to change the angle. That's absolutely mandatory. So to obfuscate that in modern times, people will try to make this experiment about the flow of ether somehow, and that because there was no angle change, therefore there must be no ether. The cool part about this experiment is that, as he's laying out here, this is independent of any ether flow, but due to Fazal's experiment showing the drag effect, it's possible that we should, have to consider that, but there shouldn't be any effect, and you should absolutely be able to measure, or, this would definitively tell us if Earth is in motion or not. So that's what he goes on to further talk about through this. So this doesn't have anything to do with there's no ether variable in the math that he goes on to use. So that's really, really important. So this is irrespective of an ether theory. This is just Snell's law and cosines based off of ratio of velocity. So here he gives the angle for deflection, which is basically reduces down to the same equation that was used earlier. So the arctan times the velocity of light over c squared, or over c, gives the ratio for the angle change. And in the medium that Klinkerfuse used with some type of oil, he said that he got a measurement that corresponded to, he said that the angle changed that corresponded to Earth's velocity. I think it was like 7 arc seconds, a 7 arc second change. So he said that corresponded to Earth's velocity in the medium that he used. Excuse me. And this is hugely significant because now we've done an actual experiment where we've manipulated an independent variable. We've added water to the telescope, which will change the outcome. It'll change the angle. It'll change the dependent variable. And that's going, that'll tell us which is in motion, sky or Earth. And just to kind of go on the reasoning there of what Klinkerfuse put forward was that the water in the telescope would carry the velocity potential of the Earth as it's moving at 30 kilometers a second. And that's going to be, translated and measured through the telescope. when you introduce the refractive index, just like they did in the interferometry experiment they did. So he was saying, if the whole lab frame is moving, if we just use that velocity, that'll tell us how much it's going to move. So a quick look at Klinker-Fuse's apparatus. So this is what he was using. Straight tube there, filled with oil, and then the eyepiece at the bottom, and then you could rotate it to line up your zennies with this.
Damn, dude, go back 1 second. All
pretty
right, hold
pretty
on.
pretty
So, like,
impressive.
So you would crank one of them wheels and it would move it a micro arc second.
Yep. Yeah. So
Holy
they had
crap.
when we get into the specs for Airy's telescope, they use micrometer screws. So like one rotation of the screw would be like equivalent to 1 arc second type thing. So they knew exactly how much they were, based on how much they moved the screw essentially.
Look at the precision machining. That's so impressive.
Yeah, dude, they were getting it. What's that?
I didn't know they manufactured for this specific measurement and experiment all the necessary tools, equipment. Like, I'm surprised they didn't build a bunker and do it in there.
Yeah, Klinker-Fuse was a pretty big deal. He was a pretty renowned physicist in Germany. So this was, a major deal, such that even Airy.
What year was that?
1867, I think.
Wow, that thing is impressive.
Yeah. So as we move on, we'll get to 1898 here. Just a recap of events. We have Wilhelm Wien, who says, recapping the successful experiments that show the Earth is in motion. It says, the aberration of light in the fixed stars, the aberration found in this simple explanation based on the emission of light hypothesis, the difficulties in the undulation theory, were only quite recently eliminated by Hendrik Lorentz by assuming ethers. So what this is AI translated, so it's kind of off a little bit, but what they're saying here is that stellar aberration gives the positive ratio for the Earth around the sun, and that the two theories are in good agreement with it for how they're interpreting how light works, one being a ballistic projectile, the other being a wave. And then he says, this is of general kinematic significance, but nevertheless taking into the account of moving or resting ethers. So again, how do we know if the sky is moving or if the ground is moving? So he calls it, a great kinematic significance, because it was understood at the time that this wasn't mutually exclusive. It was a good proof, but, wasn't mutually exclusive. And then he goes on to talk about the negative experiments that give a negative result for Earth's motion. An attempt to see whether the movement of Earth influences the refraction of light coming from the fixed stars, talking about Arago and Airy. So stellar aberration can't be used as proof that the Earth is in motion, because that was what was an experimental question, right? That necessitated the angle change when you introduce a refractive medium. And because there was no change, stellar aberration now means the sky moves. Like it's mutually exclusive to a stationary Earth. So I just wanted to throw that out there for history contextualization. Now we're going to look at Airy's apparatus and go over the tech specs a little bit. So this is what it looked like here. We have a spindle telescope mounted to the side, and then you could rotate it 180 degrees on either side of that spindle so that you could take reverse measurements of the zenith so that you could, double check your accuracy essentially. And let's see, we'll continue on here. So the telescope was mounted as a zenith instrument with the whole of the telescope tube from the lower surface of the object glass to the plane glass, closing the lower end that the tube was filled with water. So they filled the tube completely with water. There wasn't any air gaps in it. There was a difficulty in removing the air gaps from when they filled up the telescope, but that was solved by there's a little piece here where you can insert a straw and suck out the air holes, and then it'll be completely filled. So they completely filled it with water. And now we'll look at Airy's paper here. We'll get into what Airy's did now that we've got the full history on everything. So 1873. So this is after Clinker-Fuse did his thing. This is after Arago's focal length and crystal prism. Airy's is going to come in and he's like, hey, our boy Clinker-Fuse in 67 said that he introduced a refractive medium to a stellar aberration observation and found that the angle changed, and that ratio for the change is in agreement with a velocity of 30 kilometers a second. So in other words, when we do the ratio, the speed of light is the variable that changes, and the speed of the Earth at 30 kilometers a second is what they're using as the constant. So this is, and with Clinker-Fuse's reputation, Airy's, who was the royal astronomer at the time, was like, "Oh, I gotta see what's up with this, and do my own experiment." So he had the lads get together and build this for him. Shane, what do you think of this bad boy?
Whoa.
Right. All right. So if you're gonna measure a theoretical 36 hundredths of an arc second, that's the thing you want to do it on, dude.
Yep.
Seems like Clinker-Fuse had a way better apparatus there.
Dude, what is on the left? Are those dials, or is that just next to a locker in a steam engine somewhere?
Okay, so they keep this bad boy in the basement next to a bunch of other stuff.
Okay. I was like, does it have a whole control panel too?
Yeah, that's a radiator on the wall and a multiple voltage power supply on the far left.
Yep.
There we go.
So yeah, this piece actually gets mounted over here onto this white piece, this white and black piece. So these two are together.
How come I don't see the spindle where you put the water in?
The water goes in
Right
here.
Oh, nice.
Yeah.
What's funny is I questioned their method and why they didn't see the obvious point that since you can relieve or you can remove this tube, you can see the strapping that's going around the gray tube, that is the scope. You should be able to take that and completely submerge it in water as you fill it. And then all of the air will escape. The entire thing will be underwater when you seal it, and you won't have to take any air out of it. Doesn't that seem obvious?
That
I
does.
would have done it. Whatever.
That does sound like a good plan, Stone, but that makes too much sense, and we're not about that life over here.
Yeah, we can't have that. Yeah.
No, yeah, they came up with like with little brushes and stuff. So once this thing was like mounted, it didn't come undone or whatever. And they had little brushes and stuff that they would push down and wipe the lenses and drain everything and clean it out, and add change the distilled water every night. Yeah,
Yeah,
That's
those
awesome.
guys wrote the book on how to do it the hard way.
Yep. So here's a
But
cross section.
your results will not vary though.
There's a cross-section diagram, what it looks like. And this is from the east section. So the telescope part is aligned behind the spindle, so you don't see it here. We'll look at another section here. Just more of the same, essentially. And if you guys want to go look at the technical specs and get more into like what each of these pieces and stuff is, on the website I have everything broken down and labeled, so you can check those out. But basically these are just the rotation mechanisms, because I was curious about, like Shane asked, how did they rotate these so accurately? And it turned out that it was the micrometer screws, and then how much that rotates, how that would correspond to an arc second over the terrestrial sphere, or celestial sphere, sorry. And at the end here, at the eyepiece of the telescope, so after the light comes in here, gets reflected down. There is this really cool micrometer, what is it called? Grid that they have that's attached to that piece that makes this section. So they have this cross-section diamond grid. Then what they do is they'll align a star in the center of that, and then they'll measure the deviations from that. And
is actually a set of wires superimposed one set upon the other to produce a crosshair set across the middle. That's their micrometer version or method of measurement.
Yes, sir. Yep. And they use that. So basically, when the stars transit this grid, they correspond that distance in through the celestial sphere through arc seconds. So here's some more pictures of what that looks like.
Wow.
And then here's the rotation, the rotational gears. So these are all also micrometers as well, or micro screws. All right.
Have I been saying micrometer like an idiot, or is it micrometer?
No, it's
No,
micrometer.
micrometer is correct.
Yeah, Stone's saying it correctly. As soon as he said it, I was like, oh, shoot. But now I'm committed to micrometer, so sorry about that, lads.
All right. Okay. No worries.
Yep. So more tech specs here you can get into, but I'm not going to get into that. What we'll move on to is the conclusion from the paper. So Airy's was testing clinker fuses measurements that saying that the angle did change and that corresponded to the Earth's velocity. And what Airy's ended up measuring when the telescope was filled with water was a difference of 0.8 arc seconds. So a fraction of a fraction of a fraction of a fraction of an arc second of the expected measurement. And the hypothesis was in water, based off of the refractive index, that for 6 months out of the year, they would have to tilt the telescope by 15 arc seconds, and then they would have to tilt it back 15 arc seconds for the latter part of the year. And what they found was that it only had to be tilted 0.8 arc seconds. So, in other words, no difference. And he says here, I think myself justified in concluding that the hypothesis of clinker fuse is untenable. So the idea that you could introduce a refractive medium and that would cause an angle change that would correspond to Earth's orbital velocity, irrespective of any ether mechanic. It had been retained that the aberration to be employed to the corrections would be increased by 15 arc seconds and minus 15 arc seconds, respectively, and the two means of the result distance agreed by 30 arc seconds. Oh, I'm sorry, disagreed by 30 arc seconds. And with that, he definitively showed that the light rays already come in at an angle. So people interpret this as, oh, well, we know that because stellar aberration in air, we know that Earth's already in motion. So all this proves is that the starlight already comes in at an angle, which means that the Earth is stationary. Like there's no other way to really interpret that. So we'll read a little bit from Robert Sungenis and Dr. Robert Bennett's book, The Church Was Right and Galileo Was Wrong. Science claims to be logical and rational, while religion is not. The following syllogism demonstrates what the Airy experiment logically concludes. A. If the Earth moves, the water in the telescope will need additional tilting. B. But if the water telescope does not need tilting, the effect is false. C. Thus the Earth does not move, so the cause is false. So if you think you need to tilt your telescope because the Earth is in motion and you fill it with water and you don't, then the cause that the Earth is motion is false. The presumed cause. This is valid logic. If the effect were not present, then neither can the cause be present. Or if the cause were present, so would the effect. But supporting a geocentric model is unacceptable to the prevailing modern ideology. In fact, this experiment was called Airy's failure because it contradicted the heliocentric metaphysics. The term Airy's failure gives the pathological insight into the thoughts of the experimenters during this era. Earth's motion with
psychological.
Oh, thank you, sir. Psychological insights into the thoughts of the experiments during this era. The Earth's motion with respect to the ether was universally expected as the only outcome. Both this experiment and the Michelson-Morley experiment were thought to be dead ends with the understanding of reality until Einstein rescued the physical theory by ignoring the evidence for geocentrism, and Aether opting instead for special relativity, which gave a mathematical solution at the expense of logic.
Who wrote that? I want to shake that guy.
Stengenis and Bennett.
Of course, we already respected them.
Shout out to the boys. So 1887 rolls around, and they were still looking for one more way to prove Earth's motion. So that's where they did Michelson-Morley. This time, instead of measuring the angle change with the velocity ratios of Earth and the speed of light, they were going to measure the wavelength, the timing distance in the speed of light with respect to light traveling in different directions to itself, to see if they could come up with a velocity component there. And in the beginning of the paper, Airy states this, which we'll read from so we can get an idea of what was going on in the heads of the boys at the time. The discovery of aberration was soon followed by an explanation according to emission theory. The effect was attributed to a simple composition of the velocity of light with the velocity of Earth in its orbit. The difficulty in these apparently sufficient explanations were overlooked until after the explanation of the undulatory theory was posed. This new explanation was at first as simple as the former, but it failed to account for the fact proved by the experiment of aberration was unchanged when observations were made with a telescope filled with water. For if the tangent of the angle of aberration is the ratio of the velocity of the Earth to the velocity of light, then since the latter velocity in water is 3/4 the velocity in a vacuum, the aberration observed in the water telescope should be 4/3 its true value. And then we have an additional note here. It may be noticed to most writers admit the sufficiency of the explanation according to the emission theory, while the fact that the difficulty is even greater according to the undulatory theory. For the emission theory, the velocity of light must be greater in the water-filled telescope, and therefore the angle of aberration should be less. Hence, in order to reduce it to its true value, we must make the absurd hypothesis that the water in the telescope carries the ray in the opposite direction of motion. So the original experiments were done in 1870s. We're at the end of 1880s. And there's still no solid explanation for it. In the ballistic emission theory, light would have to accelerate when it hits the water. And in the ether theory, where light's a wave, it has to be carried in the opposite direction of motion. There's still no coherent explanation for that. And then at the end of the Michelson-Morley experiment, if you take those measurements at face value, and if you take the tilt of the telescope of 0.8 arc seconds at face value, those measurements are too big for for the explanations that were put forward at the time, which was that, the ether carries the light in the opposite direction for the moving telescope. And in the same sense, it would be the Michelson-Morley measurement is too big for that. To say that it's a null, to say that it actually measured 0, because 6 kilometers a second is too big of a reading. And the same also applies for Lorentz's explanation of link contraction and time dilation, because it would have measured, either within like 2 kilometers a second or, no kilometers a second. It would have recombined at the exact same time. And that would have been, they could have ad hoc used that as link contraction, time dilation. But if they have an actual fringe, they can't acknowledge that. So what Michelson says at the end here is that the theories proposed by Stokes and Lorentz also are incompatible if we use these measurements. So there's no explanation that's satisfactory. If you try to keep the Earth in motion, you have to change physics, deny actual measurements, and then just kind of ad hoc believe in it for funsies. So now we're going to get into some refutations. We're going to watch some videos for continuity and see what's out there on the internet. If your average person was to go to YouTube and type Airy's failure, what would they see? This is going to be, we're going to look at what they would see, and then we'll add some rebuttals to what's put forward. And throughout this, I actually found a couple of channels that made some really cool Airy's failures videos. So we'll watch those as well. So before we get to those, there's a couple of closing points. So from a book from Wolfgang Pauli's textbook on relativity in 1958, he talks about Airy's failure, and what he proposes is that Lorentz's explanation was very confusing and required a lot of mathematical transformations because with Lorentz's theory with an ether, the velocity is all relative to that background. So there has to be some 30 kilometer velocity component somewhere to be accounted for. So to mathematically cancel that out, your boy had to do a couple transformations. And this dude is saying that in the theory of relativity, which is mathematically identical to Lorentz's ether theory, but just philosophically different. Anyway, your boy Wolfgang says that if you take the reference frame of the telescope and the reference frame of the Earth, there's no relative motion between the two. Bam, no velocity component, thereby stating that there should be no change in the starlight. So, that's completely ignoring, and you can only do that in relativity because you're not analyzing it through like the actual system that's in motion, like because it's not absolute. So you're just arbitrarily defining two reference frames that there's not relative motion between. And you're like, this definitely solves it. It definitely doesn't solve it. Because remember, dynamically, the model is that the Earth is in motion. So there has to be an angle change regardless of if the Earth is doing an ellipse or a circle, or if it's free falling through a gravitational well and it's just all an illusion. Either way, that starlight is coming in parallel, in their model, parallel light rays, and it's the motion of the Earth out from underneath it that is causing the aberration. So if that's the explanation given, they're mandatorily locked in to the same when you apply water to it. There has to still be a change. They can't get out of it just because there's no change. But that's what this dude proposed. Just absolutely nothing. And then we had relativistic velocity addition that was put forward. So they were saying that, okay, you can't use classical velocity composition. You have to use relativity velocity addition. So we went through ChatGPT, did the math on that, and then Pizio checked it to make sure that it was all good. There was a correction that needed to be made at the end that we'll go over. But basically, the difference between relativistic velocity composition and the classical prediction is a difference between 2 millionths of a degree. So right here, the difference that they actually give, the classical prediction is 27 arc seconds. So when you fill the telescope with water, the angle change is going to be 27.52, 10, 55, 26. And then the relativistic prediction, like the difference gets out to the, 7th or 8th decimal there. So there's no saying that you have to apply relativity to explain this. It actually doesn't offer anything. It means nothing. This is physically insignificant. You would still have to have the angle change. Whether or not it changes to the tune of a difference of 2 millionths of a degree,
that would be 2 10 millionths of an arc second right there in your raw difference.
2 10 millionths. Thank you, Stone. Whether or not that's the difference is irrelevant. The how you get there is the same, and by the same mechanism that the light is slowed down. So there's no way to get around that. All right. And next up, we will look at Astronomy Live. So Witsit recently had a debate on Tim Pool's YouTube channel, and an explanation was put forward that because there's no ether, the water doesn't know that it has to translate Earth's orbital velocity laterally or something. Anyway, we'll let him break down his explanation here, and then we'll get into some refutations. And then there was a comment there where they were arguing over, this guy was like, so does the speed of light change or not? Because it's ambiguous the way that he talks about it. And, as we went over earlier, the speed of light does change, but we'll just see, explanations given where the speed of light changes, but it doesn't change, and it all just magically works out. So we'll get into all that. But here's Astronomy Live. So I'll play this out.
Stellar aberration is a phenomenon where starlight will enter the telescope at a slightly different angle depending on what time of year it is due to Earth's orbital motion around the Sun. For the purposes of this illustration, I'll exaggerate the angles involved, but in reality, the shift is only about 0.006 degrees at most. But now with stellar aberration included in the simulation, you can see that the photons of starlight are entering the telescope. Now let's make the telescope tube transparent so that we can see the photon of light traveling down the tube to the back end. Now, of course, in this example, the telescope is simply filled with air, which has a minimal impact on the velocity of light. But in 1871, astronomer George Airy tested the hypothesis that if you filled a telescope with water, which would slow the light down, that you would see an increased amount of stellar aberration due to Earth's orbital motion as the photon passed through the water in the telescope. In the 19th century, it was thought that light was traveling through a medium known as the luminiferous ether, and as Earth orbited the Sun over the course of the year, you see a shift in the star's position due to stellar aberration because the light is entrained in this medium that has a velocity vector relative to Earth that is changing due to our orbit around the Sun. This led to the hypothesis that if you slowed light down by using water or some other dense medium to reduce its velocity through the telescope, that you would see a greater amount of stellar aberration because it was thought that light was entrained in this ether, and so it would not affect the lateral motion caused by Earth's motion relative to the background ether. If we look at these velocity vectors of this photon as it approaches a water-filled telescope, it was believed that the water would slow the light down along the green axis through the telescope, but not the red line representing the amount of stellar aberration caused by light being entrained in the luminiferous ether. It's important to note that a lot of space deniers today will make this assumption implicitly. Whether they explicitly state that they believe in ether or not, they will want the viewer to believe that water should only slow the light along the long axis of the telescope, but have no impact on the lateral velocity of light relative to the telescope caused by Earth's motion. Of course, this begs...
Wait, is he completely inventing his own interpretation of what he thought Aries did?
Yeah, this guy's logically messed up.
Whoa.
Yeah.
Whoa, nice animation.
We also call that
but...
we also call that geometrically challenged.
Yeah. So again, this doesn't have anything to do with lateral velocity components. It's literally the Earth moving out from underneath the light when it's in a refractive medium because it's taking longer to get there. So the Earth has an opportunity to move further, which creates a further deviation angle. All this stuff about ether lateral velocity components is, just a detraction here. But listen to the conclusion that he comes to at the end here.
Begs the question, how would water know to only slow the light along the long axis of the telescope, and why would it do that? If the answer is that the photon is entrained in the luminiferous ether, and therefore the lateral motion is still there regardless of the light slowing it along the long axis of the telescope, this needs to be stated explicitly, and evidence for this luminiferous ether needs to be provided. In this illustration of a water-filled telescope, the photon slows down once it enters the telescope's water-filled tube, but the angle which it exits the telescope is the same as the angle with which it entered the telescope. This is what Airy observed. The water in the telescope had no impact on the angle of stellar aberration.
You
The
don't
water had
say.
no way of knowing that part of the angle that the
Is this
photon entered the
Ferguson?
telescope.
Yes, this is for Ferg.
Okay, roll on.
Makes
Yep.
sense, right? Like, this is
Yeah.
why you embarrass yourself so hard. Oh, man.
Dude,
Bad was due to Earth's orbital motion, and to leave that relative motion alone as it slowed the photon down. This is what it would look like if the photon was entrained in ether that would continue to drag the photon even as the water
this is what it would look like if the Earth was in motion, irrespective of any ether. Continue, Ferg.
slows its progress down through the telescope. Entrained in ether is just a way of saying that the photon is embedded in the medium, and therefore it will be essentially dragged through the water by Earth's orbital velocity relative to that medium, regardless of the water slowing down the progress of the photon through the telescope.
Did he just adopt our results and then claim his position was right and was like, look, it actually what it would look like if it was mine is yours?
Yep.
That's a crazy thing to do.
Yep.
Of course, this
And
is
he's
not
not even using a vertical telescope.
No, no.
To be clear, what he's showing right now is the expectation if Earth was in motion, and he's claiming it is the expectation if there was a luminiferous ether slowing it down laterally. Is that exactly what's happening?
Yes.
Seems about that. Yep.
Jeez.
Not the result that we see in reality, but this result is only predicted if the photon is embedded in a medium that maintains that lateral velocity regardless of the slowing effect of water.
Just remember, he is a neurosurgeon or whatever, so believe him. That's the only credibility that guy's got. That's the most retarded thing I've ever seen on the internet.
Hold on,
I
he's
was
got.
so ashamed when he said that on Timcast. I'm a neurosurgeon.
No,
Hold
he's
on.
into neuroscience.
Neuroscience,
He's not
yeah.
a surgeon. He's
I
not
made
an
it
MD.
up.
Oh,
Yeah.
he's got 3 seconds on his video.
Continue.
Thanks for watching, and clear skies.
All right, cool.
Really? We couldn't have cut
I
out
could-
his closing?
No.
I could feel my IQ dropping as I watched that.
Yeah.
Top Gun was cool or whatever.
So now we have comment section here where this guy's like, okay, I got a quick question for you, bro. Does the light move down in the telescope or not? Because you should have to tilt it. And then he just doesn't say anything about it and just talks about the linear lateral velocity being needed to be accounted for an ether, not really understanding it. And then this guy comes in hot, says a bunch of nothing. And then down here at the end, he says, but if special relativity holds, which it does, it's extra super true, light enters at sea and leaves at sea. Oh, no way. Measuring different aberration due to the water would be the same as measuring a different sea in the water in the telescope. That doesn't happen. Cool. So,
Yikes.
And then, yeah, dude. And then and then that guy replied back and was like, thanks, I understand it now. And it's like, no, that guy didn't say anything. You definitely don't understand it now. You just got gaslit on the internet. And like my boy Toby always says, never gaslight your own soul.
More.
Light
Don't
can't
let apparently incompetent strangers gaslight your soul for you.
right. Light can't simultaneously slow down and not slow down. It doesn't make any sense.
Look, if you were in the telescope from your own reference frame looking at the light, it wouldn't actually change. Therefore, we're good. Everything's good. Everyone can go home.
I am home.
All right. So the hypothesis that the light slowing down doesn't affect anything, right? This image wouldn't be possible if light didn't slow down, right? This is what creates that effect, the slowing down of light. And I put this together before I found the video of the girl measuring it. So that was like way better. But this was like my first go-to. It's like, this is an obvious optical effect. So you would have to be arguing, if you think that the light doesn't slow down in the medium, you would have to argue that you would see this image normally. That's what they're saying.
It's a great example.
And then further, the variance in the speed of light due to the refractive index, even accounting for the temperature difference. So like, how hot or cold the water is, the gradient. There was how do I get this to, I've made a mistake. All right. Anyway, this is the backbone of astronomy, where they introduced air at different temperatures to see how the density of the air would affect their observations for the timing and the speed of light. And they found that, they could measure fringe differences in that. So the idea that light doesn't slow in a medium is, absurd. The only reason that this comes up is because this argument, once you apply that understanding, it directly refutes the idea that the Earth is in motion. So to have both of them, you have to start saying things like, well, it does slow down, but it doesn't. Reference frame dependency. It's like, in the lab frame, what you measure is a variance in C. That's it. And if the Earth is in motion, that timing difference, they're just going to move further. That's all there is to it. It's very straightforward, regardless of any ether. So Airy. So this was just in reference to Ergo, Foucault, and the boys measuring, using an interferometer and air in different channels of the interferometer to, measure the difference based off of the temperature of the air and different conditions of it, humidity, etc. So here we have the classical velocity composition for Fresnel drag for the change in the speed of light. So the way that they say, it's constant in a medium. Well, the classic derivation for velocity addition with respect to a refractive index is given by Fresnel, which that's what Fazal tested with his water experiment with the water in the interferometer, measuring the velocity of the water. This equation was derived in 1818, and it gives no difference in what we went over earlier with the relativistic derivation, where the difference was, 10 millionths of a 10 millionths of a degree, 2 millionths of a degree. So
of an arc second, would you believe?
Of an arc second, thank you. Yeah. So just extremely no difference in these, right? So what we're saying here is that the speed of light, not only does it change in a medium, that medium can also drag it and give a velocity addition or subtraction. And this is noted in inertial navigation systems. What we're looking at here is a manual for a ring laser gyroscope that uses ionized helium, and the flow of the helium in the chambers due to the due to the ionization of the gas to create the laser, creates a laminar flow in the chamber, which basically is the gas particles are flowing in a preferred direction. And that is causing, that little amount of drag is causing the speed of light to vary, and they have to account for that when the apparatus is running. So they're actually accounting for a plus or minus to the speed of light with respect to the lab frame, based on the laminar flow of gas inside of the chamber of a ring laser gyroscope. And then we went over the video earlier, which, like I said, I found this at the end, where she measured.
What are those results again? So was that the first one, 11.2 to 14.9? What was that, a 3 centimeter difference?
33%.
Yep.
Wow. It wasn't quite clear when I was watching it, but I like how she read the results and went, nah, I went to bed, came back all fresh, new pajamas, had a night's sleep, was like, okay, I figured it out. Here's what happened. Nice. That's awesome.
Yeah. Yeah, this is a great find because this is like very conclusive. And then she actually does a follow-up video because there's apparently two different types of these laser meters. And one of them
in the comments was like, use the wrong one, I bet.
Yeah, they were like, that one uses phase velocity. You need to do a pulse timing group velocity or something, right? So she actually got the group velocity one and and did it, and it measured the same thing. So it's definitive.
Nice. Isn't that matching for Zhao's like drag test way back when, 30 to 40% or whatever?
Well,
so it's been known.
Yeah, well, the medium is stationary in this case, so it didn't measure any velocity component, but it measured the slowing of the light in the water to produce the timing difference that's proportional to the refractive index of the water.
Wasn't that like a metric that's been known for a while because people have been running light through prisms since forever?
Yeah, since the 1800s, like I said, that formula that Fresnel derived for the coefficient for the drag is N is the refractive index squared. So yeah, they already had these properties and velocities and how they would affect them with the measurements.
Funny, because now they're like, listen, in math, we can make it so that doesn't happen. We'll cancel that right out. We'll do some relativistic corrections, get some transformations. Look, boom, it's not there. And then everyone forgot. And then this chick went to measure it in reality and was like, it's not going to be there. Look, I'm going to predict that using my math, it's definitely not going to be there. Obviously, I believe in relativity, right? And she measures it and she's like, damn, wait a second. What happened? Oh, we just made it go away with math. And then, oh, shit.
Dude, it goes away with math so hard. And then they give some follow-up videos from 3 brown, 1 blue, or whatever his name is, or 3 blue, 1 brown. And anyway, what they say is they go on like a roundabout way to invoke a path length change due to light interacting with the electrons in the molecular structure of the material. And that when a photon hits an electron, it like re-emits light or whatever. So like there's this like, there's this bouncing ripple oscillation situation, expansion, contraction of the electrons in the molecular structure as they oscillate to create a path length difference, because basically the photon's going to hit an oscillating electron and it's going to like deviate from that ideal path. Like, dude, it's so,
Well, is that any crazier than rotating spontaneous pockets of time dilation and whatever?
Yeah, because it's physically just not being measured as a different speed, and they're like, well, no, but it's the same speed, but we still want the timing difference. It's like, all right, so it just spends more time in there, but it maintains the speed. It just travels a lot. Like, okay, got it.
Which experiment do you think is more lied about, Michelson-Morley or Airy's failure, success?
All of them.
I mean, they're kind of integral, right? But Michelson-Morley is lied about straight up on Wikipedia, but so is Airy's failure, right? In the very context and the naming of it.
Yeah, that is a tight race.
It is a tight one.
Airy's failure, just because the name.
I would say just because it's less known, it's more dangerous, and people get fall prey to nonsense and gobbledygook like Astronomy Live.
It's less known, and it's so straightforward that once you hear it, you have to take some absurd position like Astronomy Live did, where he's like, yeah, it just comes in and doesn't do the thing, and lateral ether velocity, you didn't know. Like, all right, dude, go back to sleep. We'll go ahead.
Sorry.
I was gonna
say putting water in a telescope just destroyed all of relativity.
Dude, you put water in a telescope, you put it in a bucket, like it's over for these lads.
A bucket.
Any sort of container, it's just like, oh, dude, and then it needs a container, so it's like, is it a glow? Like, dude, there's fractal levels of water being in a container that destroys all of cosmology. That's all I'm saying.
Man, the old boys destroyed it all with a bucket and a telescope, and then they got buried, and then everyone forgot, and here we are rediscovering the truth. Like, oh, it's already been done, boys. It's a wrap. Don't worry. All the math, it's all bullshit. It's all been bullshit the whole time.
The whole time. So, a couple of more arguments here. So, the assumption relied on the idea that light was entrained in a medium, meaning it was influenced by the motion of the medium. So, they're conceptualizing that the ether is going to drag it with that proportional velocity or something. The argument in this experiment is the water-filled telescope slowed the light speed down, but it did not change the angle of aberration. This contradicted the idea that the light was entrained in an ether, since no additional aberration was observed. So, when you do relativistic relativistic vector summation, they'll say, okay, because this was proposed on Flat Earth Fridays, that you could do a Lorentz transformation from the frame of the telescope that has a horizontal velocity component of 30 kilometers a second and a vertical velocity component of 0, but you could transform that to the frame of the photon, and suddenly the photon that has a vertical velocity component of the speed of light, 300 million meters a second, is going to have it's going to have a velocity component, a horizontal velocity component of 30 kilometers a second now, because you Lorentz transformed from the Earth to the photon frame. So in the transformation and analysis, right, you got the fixed star, so that's the stationary frame that's emitting the photon, and that's in motion, and you have the Earth that is in motion out from underneath that photon, from that fixed frame, from that stationary frame. So on the inverse, they make the Earth stationary, so the Earth now has no velocity because they're transforming it to the lateral component of the photon, and they're saying that will make there be no deviation angle. But that's incorrectly using a Lorentz transformation, because dynamically they're still assuming the velocity component of Earth to be there to compensate for there to be no angle change so that they meet at the same time with the lateral velocity component of the photon that's now been added. And that's not the way you would do it. You would still have a deviation angle if you Lorentz transformed, because it would have to be reciprocal. So because when you do the velocity composition for relativity and the classic derivation, remember it's only 2 10 millionths of an arc second difference. You still predict an angle change. So you can't make there be no angle change by adding lateral velocity to the photon, because if you did that, then you wouldn't have any aberration when the photon is air or is in air. There would be no aberration because all the photons would just have horizontal velocity components that automatically compensate such that in air, there's going to be no correction needed. So you can't even take that approach using a Lorentz transformation or doing any sort of vector summation or anything like that, because you actually ruin you ruin aberration. You would predict no aberration at all.
Wild.
Yep. All right, and then real quick on ether mechanics, and the ether has to be entrained and all this. Specifically, no. What we're looking at here is the end of Klinker-Fuse's derivation, but what he starts with is just cosines and Snell's law, so a refractive index. And that's all this is based upon. Like he stated earlier in his paper, the cool thing about this experiment is that it's independent of any dynamic ether effects. So even if you don't believe in an ether, even if you it doesn't matter. There's no ether needed for this. There absolutely has to be, in a dynamic system, there has to be an angle increase because of the speed of light being slowed. That's the only variable that changes in the experiment. That's the only thing that would produce the angle if the velocity is constant of Earth. So there's no real way around it. We got to fix that. 1 second, lads. All right, photon lateral velocity component. We actually just went over that, so that's my bad. Everything that I just went over previous applied to that, but here's the notes for that if you guys want to go back and read it. So we'll move on now to McTune's website. So mctune/Airy's failure, I think it is, something like that. I think there's a link here. Oh, mctune.net/relativity. You can find this. So where I got Klinker-Fuse's English translation, it's I got it from my librarian, but also it is posted here on Tune's website. And there's a little note preface here that says, "Note, I have not read this yet." And towards the end here, we're going to watch Pizio and Tune discuss Airy's failure. And you'll see all the arguments.
La 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 la.
We'll see that all the arguments that Tune makes are actually refuted by Klinker-Fuse. So you can just click this right here and read everything about how this was derived, because that's what I did. And then you get down here to the math, where he starts with the... What was it?
66 pages, Illuminati confirmed.
Yep. So starts with a simple sine in the angle and the velocity. That's all it is. So that's a good place to find the source here. But he puts forward the explanation that nothing about Earth's motion or the existence of ether can be concluded from this experiment. Well, that's entirely incorrect. This experiment is independent of an ether mechanism, and the dynamic asymmetry introduced by the water in the telescope necessitates that the Earth is stationary. This conclusively shows that. So this is definitive. So this is inaccurate. And then the isolation, the experiment did not detect an ether. So explicitly, as we went over, as stated by Klinker-Fuse, this wasn't about testing an ether. This was about showing the dynamics of the physical mechanism of the cause of aberration, right? Which is, if I'm not mistaken, I think it's Earth's motion is what they say is the causal mechanism. So it wasn't about detecting ether. And then, however, taken in isolation, ignoring all previous evidence of Earth's rotation, well, he means annual motion. But anyway, one could suggest that the
revolution is what he means.
Yes, thank you. One could suggest that the ether was not in motion relative to the Earth. And again, if the Earth is stationary, all the measurements, you can address them in the first order. You don't have to say that they're nulls and that the speed of light is the same. You can actually address the velocity addition and subtraction for what it is. So completely wrong on all fronts there. Then next we have a meme from Flat Earth WS that says, Airy was an experiment which failed to confirm the ether theory by measuring stellar aberration. Which proved that the Earth's orbital motion. So again,
I was just going to ask, what does Wikipedia have to say? Where are they getting that this has anything to do with the ether? And I looked away for 1 second and you already came back with it. There it is. This retarded website. That's where people get this retarded idea. Okay.
So yeah, it's pretty, it's just the same thing over and over again about that. They're making it about the ether, but again, it wasn't about that. It's very straightforward.
This shows that they have nothing. They have no idea what Aries failure was, what it did, what the paper said. They just repeated what somebody else said with no shame.
Yep. It was the change in the angle was not observed. Hence Aries failure. It helped in ruling out the ether theory. Oh, is that what it did?
Yikes, it's so bad.
It's like this was an experiment to confirm whether or not stellar aberration, if the cause of it was Earth's motion. And again, that's being very generous and assuming that there's a true position of the star for there to be a deviation to. So this is just like reifying it immediately. They're like, they falsified the causal mechanism, but because the first thing that we assumed is the reason, we're just going to fall back on that. And that's insane.
Dude, if you can't change the results, you just got to change your opponent's goal. That's not what they were doing there. That's not what they were testing for.
The more .ws memes I have read over time, the more I start to consider that entire thing is actually a flat earther op.
It's run by
and
flat
they do it
earthers.
so bad to make the globies look like such idiots that people feel driven to go and actually check out flat Earth because of how bad these things are.
Dude, there are people who are 6 years in this conversation that still post those memes. I think that they're just the epitome of the surface level regurgitated Google search 1 minute answers for everything.
Yeah, the newbies who never gave it any thought in the first place just grab some dogma and post it. And there it is again, WS,
Yep.
there it is again. Oh, great.
One time, Omnivore joined EA, and he just started talking about this bridge. And he's like, yeah, well, I don't have sources, but yeah, I know they built it using Earth's curvature. And then I was like looking up the bridge, and all of a sudden I find like the day before flatearth.ws, the bridge. Like he reads that site and then he brings the arguments to
He
EA.
internalized it into a personal story that never happened. To tell you, that's really slimy. Did FTS talk about it too? No way.
Yeah, so we're about to, my sincerest apologies before we begin. If you want to mute or whatever, go ahead. So here we go. Let's see what FTFE has to say about it.
Hey, I'm Craig. Welcome back to Fight the Flat Earth, the channel that shows how Fleur stupidity is observable, measurable, and repeatable. Yesterday, we went through the misconceptions that the pea-brained dumbass Flurfs have about the Michelson-Morley experiment. Today, on episode 5 of Explaining Simple Stuff to Flurfs, we're going to take a look at why they don't understand the experiment known as Airy's failure. If you guys are enjoying these short explanation videos, then let me know in the comments, and together we can wipe this disgusting Flurf disease off the face of our beautiful globe. Stick around for another short burst of knowledge.
We're living on a disk, floating through space, with a tiny sun. Airy's failure was an experiment that proved that the heavenly bodies are in motion, while we are not, using telescopes with water. Telescopes have to be very slightly tilted to get the starlight going down the axis of the tube because the Earth's speed around the sun. Airy filled the telescope with water that greatly slowed down the speed of the light inside the telescope and found that he did not have to change the angle of the telescope. This showed that the starlight was already coming in at the correct angle, so that no change was needed. This demonstrated that it was the stars moving relative to a stationary Earth, and not the fast orbiting Earth moving relative to the comparatively stationary stars. If it was the telescope moving, he would have had to change the angle.
The video that I've used the past couple of days is from a channel called Flat Earth Talk. I just want to ask, what is wrong with the guy? Was he dropped on his head as a child or something? Because once again, he's come to completely the wrong conclusion. The 1871 experiment by George Airy was an attempt to determine the drag on light that would change the stellar aberration of a suitable star that was directly overhead. However, his entire experiment was based on the false assumption that light needed a medium to travel through, commonly referred to at the time as the Aether. Airy filled the telescope with water and observed the passage of light into the telescope, as Aether theory indicated that a telescope filled with water would produce different effects than one filled with air. The experiment was repeated several times over the course of 6 months. Airy's experimental data appeared to show no apparent motion of the Earth, as the starlight did not behave the way expected on the heliocentric model. However, the results were skewed based on the false assumption of the existence of the luminiferous Aether. The experiment became known as Airy's failure as no motion was detected, but the actual result was the same as yesterday's Michelson-Morley experiment, and that was determined that the
results were skewed, but they also had no motion.
I love how you said that they carried on the experiment over 6 months. No, they didn't. The experiment was 6 months apart, done at the equinoxes for a couple of days at each time. Just insane. Oh yeah, he's got a PSYOP dance shirt on. It's just awesome watching this guy.
How gay is that?
Incredible fallacy factory.
Pretty gay.
The Aether did not exist. So, once again, if a simple-minded flurf comes up to you and says that Airy's failure proves a flat Earth, you can tell them directly that they are talking shite. I hope you've enjoyed these couple of shorter videos. I plan to do a lot more on things like this.
Yeah, so we actually don't need to watch the full outro for this one. We're good. But yeah,
also, I've never seen his intro before, so thanks for making me watch that for the first time.
Yeah. We titled as Craig's failure.
While he was doing that.
Yeah, so no actual explanation, just gaslighting and flaming flat earthers. Very cool.
That's actually it's entirely expected.
It's about standard issue. So yeah, what can we conclude from that?
If you can't beat them, join them. Really manifest. If you can't change the results, just like retroactively change your opponent's expectation and goals.
Yeah. So this guy, I'm going to save us the 10 minutes and. Because this is like a 0 tier, but this guy's video popped up when I looked for Airy's failure, and he didn't really have any idea what was going on, but he came to the conclusion that light doesn't slow down in the water, but we already covered that extensively, so we'll just skip past that. But that was his immediate explanation. And also regarding, shape of the Earth, I personally wouldn't use Airy's failure as an argument to argue that the Earth is flat, but definitely that there's no motion. And the gaslighting he did at the end and ad homs to that dude who made that video, like right after he says that there was no motion detected. It's like, all right, dude, let's not forget what you said. So here we have, I Can Science That, who's got an Airy's failure excerpt here. So we'll skip to that. Oops.
Airy's failure was.
Oops.
Did they all start this with that video? They all picked on this kid 1 week. What did they all get together and make a plan?
No. This is some sort of an error. Anyway, we'll go up 1.5 because talk's a little slow.
Frequently comes up when discussing this topic was in 1871 and has become known as Airy's failure. The theory goes something like this. Imagine the light from a distant star coming towards us through the ether, like this raindrop falling through the air. A telescope is acting like this test tube, catching the raindrop, the photon, at the bottom. But we know the Earth orbits the sun. To imagine the effect that has, let's put our cowboy on the train again and have him try to catch the raindrop. The raindrop is falling down with speed v rain, and the train is moving to the left with speed v train. Relative to the cowboy, that makes the effective velocity of the rain v relative, diagonal. The train represents the motion of the Earth, and the raindrop is a photon traveling through the ether. So now the raindrop hits the side of the test tube instead of going straight down it. To catch the raindrop, we need to tilt the test tube parallel to the relative direction of the rain. Remember that the train represented the orbit of the Earth around the Sun. So 6 months later, the train is going the other way. That would mean the cowboy would have to tilt his test tube the other way to catch the rain. Indeed, we do find that we need to tilt our telescopes very slightly at different times of the year to see the same stars because of this, and we call it stellar aberration. James Bradley had actually figured this much out by 1728 when he was still working with the corpuscular theory of light. Once it was clear that light was a wave and people started talking about the ether, stellar aberration meant that the ether must not be moving with the Earth. Otherwise, this effect wouldn't happen. This brings us to Airy's failure. It was known that light travels slower in water than in air. Airy reasoned, as others had before him, that the presence of the water slowed the light's movement through the ether. He reasoned that this slowdown shouldn't affect the component of the light's velocity caused by the motion of the Earth. As this diagram shows, this would presumably change the angle of the light, or the raindrop, travels through the telescope, the test tube. Airy figured that the angle of the stellar aberration would be different if he filled his telescope with water, and in 1871 he went to some effort to test this. Well, he tested it, but he didn't find what he expected. Airy discovered that the angle of the stellar aberration was exactly the same, whether he filled his telescope with water or not. And that is why we call this experiment Airy's failure. The flat Earth community likes to suggest that this is evidence that the Earth is not moving after all. But there are two major flaws in that argument. First, it's extremely obvious now, as it was then, for a multitude of different reasons, that the Earth is orbiting the Sun.
What are the reasons?
We forgot to pre-assume it. We forgot to pre-assume it. How could we, dude? My bad.
What are the multitude?
Second, this interpretation.
Oh, there's none. Now we're just going to move on. We're not going to list the multitudity.
Just said it. Just to say
No,
it.
he said it. He's like, the reasons are we already knew it was in motion, silly. Duh.
The guy sounds like his microphone is in the toilet.
Yeah, this is not his best audio video. This is an old one, but yeah, it's not great.
Interpretation assumes that Airy and his contemporaries were right about the nature of the luminiferous ether, something we now understand to have been incorrect. When researching for this, I found very little on Airy's failure from mainstream academic sources. The more conspiracy-minded would have you believe this is because we're trying to
terrified.
What'd you say, Stone?
I said on Google. Yeah.
Cover something up. But it seems far more likely that Airy's failure just isn't very interesting to the academic community. Airy wasn't even the first person to attempt this experiment. The Michelson-Morley experiment that followed is far more...
All right, then he goes on to talk about Michelson-Morley and how that showed that relativity is true and that there's super no ether and Einstein is a super smart lad and so on and so forth.
Yikes.
All right, so now we'll get to the good stuff, man. Now that we've been through the torturous explanations of the relativist, we'll now listen to some good stuff. So this is a channel that I found. I'll link it. You guys can sub to him. He made a Airy's failure video. Here we go.
Airy's experimental data appeared to show no apparent motion of the Earth, as the starlight did not behave the way expected on the heliocentric model. The video that I've used the past couple of days is from a channel called Flat Earth Talk. I just want to ask, what is wrong with the guy? Was he dropped on his head as a child or something? Because once again, he's come to completely the wrong conclusions. Airy's experimental data appeared to show no apparent motion of the Earth, as the starlight did not behave the way expected on the heliocentric models. Airy's experimental data appeared to show no apparent motion of the Earth, as the starlight did not behave the way expected on the heliocentric model. The 1871 experiment by George Airy was an attempt to determine the drag on light that would change the stellar aberration of a suitable star that was directly overhead. However, his entire experiment was based on the false assumption that light needed a medium to travel through, commonly referred to at the time as the Aether. Airy filled the telescope with water and observed the passage of light into the telescope, as Aether theory indicated that
We can skip
filled with
this
water
probably.
would produce different effects than one filled with air.
God, it's about as long as I could hold.
Yeah, it was the appropriate amount of time just to just to resalt the wound or whatever. So he goes on to Google here. He goes on to Google about Fazal drag, so showing that the speed of light is different in a refractive medium, which is what we covered earlier. And then there's no such thing as a partial ether drag. There is simply ether drag, which is quite literally stating that the movement of a medium such as that of air or water will affect the speed of light. the allegedly universal constant and the foundation of special relativity. I'll narrate for him. All right. Which is why when the 7th Astronomer Royal, Airy, failed to detect a difference in stellar aberration.
Airy's experimental data appeared to show no apparent motion of the Earth, as the starlight did not behave the way expected on the heliocentric model. However, the results were skewed based on the false assumption of the existence of the luminiferous Aether. The experiment became known as Airy's failure, as no motion was detected, as no motion was detected, as no motion was detected, as no motion was detected. But the actual result was the same as yesterday's Michelson-Morley experiment, and that was determined that the Aether did not exist. But the actual result was the same as yesterday's Michelson-Morley experiment, and that was determined that no motion was detected.
Fresnel's famous Aether drag experiment proved Fresnel's theory of partially dragged ether. Okay, here's the deal. Fizzy proves the moving medium affects the speed of light. This comes to be termed as partial ether drag, which the terminology is ludicrous for the reason already given. Ether drag is already a confusing term because it's a concept that's being used in the heliocentric mindset, which does not make sense. What ether drag actually means is that the medium, like water, can be shown to slow down light. Heliocentrists think this means that there is a rotating ether infused into matter or something of that sort, and that there is a denser matter that causes a noticeable drag on light. To be completely honest with you, heliocentrists do not themselves know what they believe, as evidenced by the man they featured so prominently in this video. The arguments are inconsistent and logically absurd. Fresnel's ether drag coefficient is still used today for F's sake. And then here's a video, or here's a clip from FTFE's channel's comment section from Jack Dorff. I would like to be clear about this. Are you stating that light does not have a different rate of propagation in various refractive indices? No, not really. Light itself, whilst it is traveling, always moves at c. What's happening is that light is being absorbed and released at different speeds. Okay, I see. Thanks for your response.
That's a good one.
Dude, Jack Dwarf, you gaslighting your soul, brother.
That's a fairy tale.
Thanks for that gem of knowledge. Can I suckle up some more? My God. Well.
So, does light slow down in water? A simple Google result from the local propaganda machine will tell you yes. And then we have the introduction to this gem here. So, shout out to this guy's channel. This is where I found the experiment from her.
Had a simple question ruin your life? Of course you have, right? Like, it's perfectly normal to spend months and months doing nothing else but obsessing over a question that no one else cares about. Like, does light actually slow down in water? I know you probably think the answer is obvious, light definitely slows down, like we learned that in high school, but I've never really believed it. Like, it just seems odd. In Einstein's theory of relativity, the speed of light is this super fundamental thing. Got the laser meter, and now what I'm going to do is that same experiment again. I'm going to test how far this meter thinks the distance is from the top of the strap to the bottom, and I'm going to do it once without water and then once with water. Okay, it gives me 11.2 centimeters. If the old distance is like 11 centimeters, then the new distance should be approximately something around 14.5. Okay, so if the result is like approximately 11 centimeters, then that means that the speed of light in water is about the same, whereas if it's about 14.5, then it means that the speed is significantly slower. So let's see. Okay.
Don't you love buckets of water?
Certainly do.
And
dude, if you look closely, you can see the convexity of the water. There's actually a hyperbola forming in it.
Yeah.
Wow, that's crazy. The lab frame is moving.
okay. I think that's a positive result.
She definitely had a phase, dude. That's hilarious.
Yep. So yeah, shout out to that edit. That was a cool video. And then we have this lad's going to explain Airy's failure as well. And here's his channel. You can check it out. Send him a sub.
Dude, she's gonna come out as a geocentrist soon. Someone should track her and let us know when that happens.
I've always wanted to answer this fundamental question: which rotates, the Earth or the stars? You would think it would be easy to solve, but in fact, you probably think the answer was proved a long, long time ago. But you'd be wrong. No scientific experiment on Earth has ever proved the rotation of the Earth, despite many, many experiments having been performed through the years.
You got any volume room on this one?
Yeah, his mic's a little quiet. You might have to turn it up manually.
Good stuff.
I taught. I wonder why. However, the criticism continues in no uncertain terms. They say things like the old experiments did not have enough accurate equipment. There are too many errors in the measurements. Light travels too fast to measure, and not the best scientists were doing the experiments, etc., etc. But most importantly, these naysayers do not put these experiments in the scientific context of the history of their time, and indeed, therefore, the consequences they had. So enter Sir George Biddle Airy, who was an English mathematician and astronomer, as well as the Lucasian Professor of Mathematics and the 7th Astronomer Royal from 1835 to 1881, and he had many achievements. But in his role as Astronomer Royal, Airy established a new prime meridian at Greenwich in 1851, which became the definitive.
Oh yeah, that was also our boy.
In 1881.
Shout out to the homie.
A fellow of Trinity College, Cambridge, and in 1836 he was elected a Fellow of the Royal Society. So Airy was one of the top scientists of his time.
Yeah, but we can't cite it because that's appeal to authority, right?
Was the highest position that an astronomer could get. And
anyone in the Royal Astronomy Society is not our friend.
It made him one of the top scientists in the world. Now I say all this because historical context is important and can be easily overlooked almost 200 years later. As Astronomer Royal, Airy was looking for a change in stellar aberration. Now aberration is a phenomenon where celestial objects exhibit an apparent motion above their true position, based on the velocity of the observer. It causes objects to appear to be displaced towards the observer's direction of motion. But simply put, he was looking for a wobble in the star. So he decided that he needed to slow down the speed of light, enough for Earth's velocity to have an effect on where the star ended up when viewed through the telescope. First he viewed an almost overhead star by using a normal air-filled telescope and tilting it slightly until it was at the centre of observation. Then he filled the telescope with water to slow down the speed of light inside, and then observed any change.
What do you mean almost overhead? It was exactly 90.
Which should have moved within the telescope.
Couldn't be more 90.
Calculating such as if it was indeed the Earth moving. However, Airy failed to prove this, since the starlight's angle did not change, and so instead he proved that the Earth was not moving. So the experiment became known as Airy's failure, and proved that the stars move relative to a stationary Earth and not the other way round. So within the context of the scientific world, this shook the establishment. Remember, this was the time of Darwin and others, all of whom wanted to remove the idea of a creator God and instead replace him with ideas of evolution, natural selection, millions of years, and a huge universe. Should the stars revolve around the Earth and the Earth were at the centre of the universe, this idea would be abhorrent and inconceivable to the beliefs and religion of scientists then, and indeed ever since. So Airy's experiment was written off as a failure, but it should, and even now, give you something to think about.
Nice. Shout out to the homie. Nice video.
That guy, whoever that was.
Yeah, awesome video. And here we're going to watch a classic from our boy Malcolm Bodum.
That video was a banger.
Yep.
If a telescope is pointing at a star and both are stationary, then obviously the light comes straight into the telescope. In 1729, Bradley found that he had to tip his telescope forward very slightly to get a star in the centre of his telescope. It was assumed that this was due to the motion of the Earth around the Sun. Let us assume that the telescope was moving at 5 miles an hour and had to be tipped 5 degrees. This 5-degree tipping, however, could equally be caused by the Aether moving at 5 miles an hour, carrying the stars around the Earth. As we see here, the light would be coming in at the same angle, and the telescope would still have to be tipped 5 degrees. So tipping the telescope does not tell us whether it is the starlight moving or the telescope moving. However, there is a simple experiment that can determine whether it was the Earth that was moving or the ether and starlight. All that you had to do was record the tipping required for any particular star, then fill the telescope with water, which greatly slows down the speed of light in the telescope. So here is the moving telescope filled with water, tipped at 5 degrees, and you can see that the starlight does not now reach the eyepiece at the bottom. This is because the starlight moves much more slowly when passing through water. However, if the telescope is tipped further, say 10 degrees, then the starlight will then be visible again in the eyepiece. It has to be tipped further because the light is now slower when in the telescope. But if the starlight is going past the telescope at 5 miles an hour, then when it is filled with water, no further tipping is needed because the light is coming in at 5 degrees anyway. The starlight stays on the same path but is only travelling slower in the water. To recap, if it is the telescope that is moving, then when it is filled with water, it has to be tipped further to see the star. If the telescope is stationary and the starlight drifting past us, then it does not have to be tipped further. In 1871, George Biddle Airy, the Astronomer Royal, performed this experiment. This is a copy from his original report. You can see that the two readings are virtually identical. If it had been the telescope that was moving, Airy expected a figure of 30 seconds of arc. In fact, he only managed to read 0.8 seconds of arc difference. Bradley first discovered stellar aberration, and it is interesting that in his report, Airy mentions that it was now about 100 seconds of arc, and that it was still slowly diminishing. This indicates that the speed of light was still decreasing in measurable amounts when Airy performed his experiment in 1871. The result of Airy's experiment, known as Airy's failure, was that the telescope does not have to be tipped further. This proved that it was the incoming light that was moving past a stationary telescope fixed to the stationary Earth. What is interesting in his very brief report of only 4 pages is that not once did he refer to the astonishing results that the experiment proved, that the Earth was stationary. This experiment was also dismissed by Wikipedia, which said, Aether drag test, under the main article, Luminiferous.
Oh, okay. That's where.
By means of a water-filled telescope, Airy, in 1871, looked for a change in stellar aberration through the refracting water due to an ether drag. Like in all other ether drift experiments, he obtained a negative result. This is a gross distortion of the truth. That he did not have to change the angle proved that it was the ether drifting past the stationary surface of the Earth. This experiment is never taught to university science students. They might begin to question what they were being taught about the cosmos, the universe, the Big Bang, evolution, and much else, if it was realized that the Earth really is at the center of the universe, which is rotating around us, as the Bible always clearly states.
Shout out to Malcolm Bowden. Bowden holding it down.
But that in itself is also the reason why Airy did not suggest that as a conclusion in his paper, because of his audience being the observatory guys who would see that conclusion as heretical. And he would have announced it. And who wants to give up that kind of paycheck, right? So all he did was present the data and let people draw their own conclusions.
Yeah, that's interesting because I personally have taught to a world-renowned astronomer who knows that the Earth is flat, but he can't admit it because it would basically destroy him.
That effect is ubiquitous.
Nothing to gain, everything to lose.
Yep. And I put a link here. Witsit did a hour presentation on Airy's failure about a week ago. It's a really good one. Highly recommend. Covers it. Has some good animations. We're going to skip over that, though, and let Pizio, the Crystal Wizard, play us out.
Oh, yes. Oh, wait till you hear this, Joe. It's beautiful.
So keep in mind, before we watch this, everything that we went over tonight was directly refuted in the paper that Toon has uploaded to his website with a parentheses around it that says specifically, I haven't read this yet.
Also, keep your eye out for every time he points to Einstein in a hand wave dismissal without ever providing figure.
Yep. And then for a reference to the actual figures, in this presentation, we showed that the difference that Toon is falling back on is 2/10 millionths of an arc second, which is not a real that's not a real thing.
Alan, is it possible to go full screen on this one?
Ooh, you know what? It certainly might be. Let's give it a shot. We'll have to reshare the audio, but I think we can do it. Do you want to see the visual, like body language or whatever?
You got to see McToon's body language.
I got you. What's Dave's YouTube channel?
I could do without it, but that's okay.
Yeah, the boys want to see it.
Okay.
But actually, I agree with what Shane said.
Cool.
I have a question.
But we are going to watch it in full screen, though. 1 second. So if you're able to see the chat, look at what people in the chat are suggesting as answers as well. They're like, the speed of light changes, it doesn't change.
Yes, the comments are so entertaining in that one.
Nobody knows. They're all conflicting with one another. All right, give me 1 sec. Gotta change the audio. Should be good.
I have a question.
There you go.
Yes. Is that okay? They tagged me to come in here and ask you because you said you wanted to just ask me about my question. So if you're familiar with Airy's failure, I just want to know if you have an answer as to why the aberration angle in Airy's telescope didn't change when it was filled with water.
Yes, because the Clinker Fuse's undulating theory of light predicted that as the Earth moves through the ether, the luminiferous ether, that the light would slow down and that it would then hit the side of the telescope. And so when that did not happen, then they were kind of confused because they were looking, they thought the undulating theory was correct. And so it confused them that it didn't work. So what happens is the light slows down in an external reference frame, but within its own reference frame, it's still going the speed of light.
So what about the emission theory, though? Because isn't that what we use now?
Yeah, it's essentially the emission theory. Yep.
But in the emission theory, the light gets slowed down by the water. So it's still a slower velocity.
Yes. So the emission theory. The emission
ratio of the velocities.
Yep. So the emission theory is essentially, I said essentially because that's within our reference frame. But general relativity, special relativity is the better understanding of it. So within special relativity, the light slows down in the reference frame of the water from an external reference frame. But within the reference frame of the water, which is the only place that the light is moving, it's still moving at the speed of light. So inside the water, it's moving at c.
Wait.
Dude, actual word salad.
Wow. Just
in the lab, the telescope and the water and the Earth all move the exact same. they're all a part of the lab frame.
But the light travels at the speed of light in water when it's in the water. And it's a 3-dimensional thing, not a 1-dimensional thing.
Clinker Fuse believed in a static ether, but that's kind of like a straw man anyway, because the description that they believed in that would explain it with ether was one in which the ether caused the light to move, because you can't tell just looking at the telescope and the light by itself if it's Earth or if it's the starlight that's moving. So they said, okay, let's put water in it, because the formula for the aberration angle is tangent theta equals Earth velocity over light inside the telescope velocity. So once we put water in it, that second variable, the light inside the telescope velocity, will be a smaller number, so the tangent theta angle should be a bigger number. It doesn't matter which model you're using, because that's the formula in every model. That's the formula we even use today. And we know that light slows down in water.
Yeah. Like I said, it's still moving at the speed of light in the water.
But it doesn't.
But you apply special relativity. And right, they're different reference frames.
Oh, there it is.
You just don't get it. It's different, okay?
There's nothing moving at relativistic speeds. This Earth's only moving like 66,000 miles an hour or 30 kilometers a second. It's nowhere near the 10% or more speed of light needed to apply relativity. Any relativistic calculation is going to be equivalent to the small angle approximation, which is equivalent to the tangent theta angle equation at these velocities.
Yeah. Yeah. So yeah, you're just going on pure emission theory and not taking into account special relativity. That's okay. But that's not obviously
Dude, how
what
can you
works.
condescend from way down
since
there?
the motion of the Earth has been confirmed externally to that previously. So this one thing contradicted the emission theory, but it didn't make any of them say, "Oh, I wonder if the Earth is not moving," because there's several other things that confirm that the Earth is moving. So
well, if
it wasn't
in the frame of the water, the light doesn't change speed. If you say it's still C in the water, at the two ends of the water, there's a speed change. So in the water, it would be C plus or minus V, because we still know that the light has got a drift, a sideways drift on it, because that's the only way it reaches the eyepiece center. That's why the tilt has to be applied. So if in the frame of the water, it's C plus or minus V.
But
that still breaks relativity.
No, it doesn't. Is the water also moving laterally?
Everything on the Earth system in the lab is moving laterally if Earth's moving.
There you go.
There you go.
But if it is, then it moves out from under the starlight, and that's why the telescope would have to be tilted. So when you add water, the tilt has to change because the velocity of light is different in the lab frame.
Given how the length of the telescope, how many nanoseconds will the light be passing through the water?
Well, that's not really
like picoseconds.
That's not really the issue. The emissive theory without special relativity is doesn't explain it. And so he's right. He's right on that the emission theory. So if you read the beginning of especially if you read the beginning of Michelson-Morley, it talks about the emission theory of light, which kind of goes back to Newton. It's popularized back then that it was particles or corpuscles of energy, and they were emitted. Thus the emissive theory.
That's
so
corpuscle.
We still use that theory today.
Also, let's not forget now that we have instruments, and even in the amateur days in the late 19th century, that you can measure the stellar aberration, which is precisely the shifting of positions because of Earth's motion around the sun.
Yeah.
But there's only two variables in the formula. That's what I'm trying to get at. The formula is super simple. The tangent theta angle equals Earth velocity over light in the telescope velocity. So if you change either of those two variables, the tangent theta angle has to change. You can't have the same tangent theta angle if you change the two input variables.
Yeah, and where you missed the part where you need to apply special relativity.
Can you
Get that
provide
magic sauce in there.
any links to any resources that show a calculation that fixes it in relativity with special relativity? Because the change, as we measure it in the lab frame, that's where the tangent theta angle approximation is used. There's no, they don't calculate it in the, in some relativistic coordinate system where you apply. Where you take the frame of the water and say C is C in the water. We know dynamically that the water slows the light down, right? Because if you go to the frame of the water and say the speed of light is C in the water, then as soon as the light leaves the water, it's speeding up and it's exceeding C. So it would exceed the speed of light in that frame if you force light speed to be C in the water. As soon as it leaves the water, it speeds up past C. You can't have that.
Yeah, and like I said, if you want, I can provide them. I don't have them handy though. Like I said, and to one more time. One more time to reiterate that the water is also moving laterally. So okay.
There's a second problem with it too. Because other than violating special relativity by forcing light speed to be C, there's also Snell's law, which states that if light hits a refracting medium such as water at a non-perpendicular angle, it will introduce an additional refraction angle into the system. And so if the light travels vertically, it won't do that. But if the light comes in at an angle, it will do that. And if the telescope is tilted and the light's coming in vertically, when you add water, it would have to change the angle from that reason as well. So the fact that Snell's law being applied in the system actually doesn't create a real physical refraction angle in the water means that the light's already coming in at that angle as well. And the only way it can already be coming in at that angle is if Earth is stationary.
Are you talking about the interface between the lens and the water? Or the interface between the lens and the air?
The lens, when the light enters the water, right? Because you have a stream of light coming, what's assumed to be vertically, right? If it's just starlight streaming towards the telescope. But if Earth's moving, you then have to tilt it. Well, when you tilt it, it's coming in vertically and it's a non-parallel or non-perpendicular surface now because the telescope's tilted.
But when you tilt it, you've now made it straight in relationship to the light path.
No. It's already straight. The star's at the zenith.
Well, the star is sigma.
It's a zenith telescope. It's a zenith mount.
No, it wasn't. It wasn't straight up. It was at an angle, right? But it was
gamma.
I forgot the name of the star.
It
wasn't. A zenith mount telescope. They used 2 spirit levels to level it off to make sure it's at zenith, pointing to the true position of the star, as according to the almanac. And then they look in it, and then based on optics, they see what the arc-second correction is needed to center it, and then it becomes tilted.
Okay.
But then when they add the water, since it's tilted, now there should be refraction introduced from Snell's law as well. So there's actually 2 sources of additional angle correction that should be input, but none was needed.
Did you calculate the predicted change in angle?
Yeah, they said they believed it would be close to 30. I mean, if you just take the 20.2 or whatever it is and do 4/3, because the speed of light in water is 3/4 that of C, then that means the angle change would be 4/3 of the standard angle. So since the standard angle is just over 20 arc seconds, it bumps it up to like 28 roughly, 27, 28, close to 30. But it didn't change. So in order to analyze it, you can if you make the Earth stationary, right, and you add velocity to the water to change it to catch up to that extra angle, you'd still need a correction angle. The only way that you can make it work is if you treat the system in which you're measuring it in as stationary, and you treat the light as already coming in at that angle.
That cat hates life.
So you have to use a geocentric coordinate system in order to make the physical observation as was made work.
How's that for a new collection tactic?
Sorry, I was handed an orange cat. Thank you.
That's what that noise was.
Yes, that was that cat named Turtle. He was cranky because the dog.
Well,
at
least we
here.
got the cat's name. The cat's name
now
was
the
what I
dog's
was
trapped
hanging
in
on the
here.
edge of my seat for. So I'm glad that we got there in the end.
Anyway, Yeah, the water is moving, and the key part of it is that the water is moving along with it. But anyway, if you want, I can send you some additional resources, or we can set up a time to have a conversation.
You can go to my website where you can
send the papers.
Where you can read the papers I didn't read.
You can't.
But like I said, I don't have them handy. So I don't have them even in my notes.
If you say the water's moving with it, though, you can't analyze the Earth as stationary for the transformation with respect to fixed stars and have an Earth that's not fixed. You're making both velocities. You're putting both velocities under transformation, and that violates Lorentz symmetry, even under a relativistic paradigm.
All right, so what is your position? Are you a geocentric glober?
Concave Earth doesn't have this problem.
Dude immediately was like, so what's your position then? Are you a glober, geocentric, or flurfer? Because I'm a flurf debunker.
Yeah, I'm going to add hom you. Just want to know which way to go.
Exactly.
Yeah, so Airy's failure proves geocentrism. It has nothing to do with shape.
But you didn't answer the question. Are you a geocentric glober?
That is not
here
the
to discuss
question.
motion.
Okay.
Right. So I'm a Bible believer.
I'm here to discuss shape.
But you can't have
no,
you can't have heliocentrism either. So
Robert
Jesus Christ
Sungenis
is Lord.
aggressively disagrees with you.
well, I think that the Bible is always historically taught geocentrism. It always was taught geocentrism. People didn't stop believing in it until the modern era. Even the church opposed it when it first came out as a heresy, and they were right because the Bible clearly teaches it. They had to adopt modern post hoc explanations and eisegesis of the text in order to insert heliocentrism upon it. But it clearly teaches geocentrism, and that's what the experiments show as well. The first historical famous one being Airy's failure.
Unfortunately, the movement of the Earth is
I appreciate the papers.
Yeah. Now, Bob,
Unfortunately, as Mike said, the motion of the Earth has already been established by other means.
It's not in question. Don't worry about it.
It's not subject to. That's not the subject of the experiment.
Yeah, I can list them though. James Bradley in 1720.
So wait. So keep in mind, boys, we're about to hear this list of experiments that mutually exclusively already proved the cause of aberration. Here we go. Ready?
27. Aberration, which of course,
aberration, which is already in question. Okay,
which of course is this topic, right? So then you asked me. All right, I won't list them if you don't want me to.
Wait, what was the other one? Here we go.
Of course, parallax from Bessel.
That's not it.
In 1836, I think. You've got Vogel and Schneier.
That's not mutually exclusive. It works equivalently in a geocentric paradigm. Parallax.
How about you let him finish?
Okay, so obviously he doesn't want me to. He doesn't want me to finish. Thank you. We'll talk to you later, but not now, since I don't get to finish.
God bless you, man.
Don't want to hear it.
I don't care.
Don't care. When you talk like that, I don't want to hear about your God. I'm not impressed with your God.
What a satanic
so sad.
Pretty sure he said he's a Christian at one point.
No, that's just to piss off Jesus people, dude. He just likes to get everyone with the troll.
Yeah, when McToon first started interacting with me, I blocked him immediately because I don't even know the guy, and he came out of nowhere, and sent other people to harass me, and just was leaving harassing statements, calling me a Satan worshiper, and it was weird, man. It was really weird.
Yeah, their only superpower is they have a bunch of troll zealots that they can direct at people, and they do get annoying. But that's pretty much the only thing they can do.
Yep. But enough about them. Let's wrap up this with the conclusion. Well,
that was very long.
Yeah, it was long. It was longer than you would expect for a telescope filled with water. But with all the obfuscation and everything surrounding it, had to get all of the arguments in put in a single location or whatever to go over them.
Yeah,
but yeah, when you have
you covered everything.
But yeah, when you have the full historical context of it, it was to definitively test the motion of the Earth, to provide a definitive answer: is the sky moving, or is the Earth moving? And this wasn't what was measured, and since it was measured, there's been no explanation put forward that gives an actual answer to it. You know, the water can't change and also be the same. I'm sorry, the speed of light going into the water can't change and also be the same. If there's no angle change, then the implication is that the Earth is stationary. It's really that simple.
But you're forgetting to apply special relativity.
Oh, and general relativity. You gotta use two relativities. One slightly curved and the other one's super flat.
But yeah, dude, I'm glad you put it all together in one spot. We went through all the mainstream refutations, the ridiculous misdirect, the recontextualization of the actual aims and goals. I'm glad we started with the words of in the paper of the guy himself, went through his apparatus, then went through what people claim he was trying to do after we eloquently heard you explain exactly what the goal was. We saw the instruments, we saw what they were doing, and then people were like, well, you see, they were measuring ether, right? And boom, no ether. So there you go. That's Airy's failure. What? what? And the other guy making up his own sort of interpretation of perpendicular angles that would need separate velocity vectors that through vector sum addition I can actually make wrong. What? That's also amazingly retarded.
Speaking of perpendicular angles, that argument that Pizio touched on towards the end there regarding Snell's law. So remember, the telescope is filled entirely, so there's no gaps, there's no points where the water is going to be level, right? Because if you were to tilt a telescope that's like half filled or something like that, the water is still going to be level in it, meaning the starlight, regardless of the tilt of the telescope, is going to come in directly perpendicular, and there's going to be no like Snell's law is not going to come into effect for the change in the angle due to the angle of incidence. It's not going to add to it. But if the starlight is coming in parallel and we're moving out from under it, when the telescope is tilted from its zenith, that's going to trigger Snell's law, and you're going to have an additional angle change that has to be compensated for because your telescope is no longer directly perpendicular to that light ray, or I'm sorry, parallel with that light ray that's coming in. As you're moving perpendicular to it, there's going to be an angle change there, and that's going to, further increase it. And even that's not measured. So the fact that they didn't even have to like go back and look at it like, oh, there was an additional change here. What happened? Oh, Snell's law. The fact that didn't even happen for, like he was saying, comes in at that angle. There's no way around that. For all these people that believe in Snell's law and refraction, and we can just, apply R squared or whatever to the radius of the globe to increase it with refraction. It's like, okay, do you guys even know what what that actually means? Because suddenly now refraction doesn't have any effects. It doesn't change the speed of light. So there should be no lifting of the radius of the Earth or moving objects behind curvature. There should be none of that. But anyway, that's the history of Airy's experiment regarding zeniths and refracting medias. If there's no further questions, comments, or concerns, I'm going to wrap up the stream.
Kick it to miss.
Nice.
I would just like to say real quick, it's called Airy's failure.
Failure for the ether. I know, right?
Oh, right. Sorry, I must have just missed that whole part. I blacked out during the whole presentation.
What? No. Dude, every Glober came up with their own explanation for why it was actually entitled Airy's failure. It was like they were trying to solve their secret mystery. It was crazy.
They were all trying to come up with their own one.
It's like the one time they don't actually have a conjoined answer.
Yeah, you should have asked Airy. He had pretty clearly. Anyway.
Well, the mainstream's pretty ambiguous. Like I said, they give velocity composition, which doesn't change anything. They give a Lorentz transformation in vector summation or velocity vector summation. They try even taking the reference frame of the telescope with respect to the Earth and saying, well, there's no relative motion between these two bad boys. Therefore, that light ray is going to come in directly parallel. They don't even have an explanation. So I don't blame the current lads for not having a good one either.
Great presentation, brother.
Thanks, man. So to finish out the week, we'll be doing research and reading night on Thursday. Tune in for that. And then Friday, of course, will be Flat Earth Fridays, episode 122. Then on Saturday, I'll be doing another Aries presentation on Earth Awakenings at 10 p.m. at 10 p.m. on Saturday. Then we'll go from there. And then next week, I think I might be doing a TikTok with Linnell from the Flat Earth Gang over on the Clubhouse app, where I'll be presenting Aries on there as well for the TikTok lads, for the talkers.
Nice.
Those are Eastern time zone for reference.
Yes, sir. Always Eastern. Thank you. All right. See you guys later in the week.